Lesson 8-8, page 272, Converting Fractions to Mixed Numbers. Here we're given an image of a mixed number. We have a whole would be a hexagon, as we see here. So one hexagon is worth 1. And so what would it be if we had 1, 2, and 3 hexagons, and this one with a fraction missing? Okay, so if one hexagon is worth 1, we have 1, 2, and 3. We simply type 3. And this hexagon here has been broken up. That whole has been broken up into how many pieces? 1, 2, 3, 4, 5, 6. So we understand that the bottom number, the denominator, will be 6. And we have 1, 2, 3, 4, 5 present with 1 missing. So we have 5 out of 6. If we were to continue to cut all the holes in fractions of 6, then we could count 6, 12, 18 plus 5, 23. So we actually have 23 out of 6. But we know how many 6's are in 23? 3 of them. And we have a remainder of 5. Okay, this is another way to write it. For the second part, we have to write from numbers 1 to 4, write the following mixed numbers as fractions. Really what they're asking you to do is to write them as improper fractions. Okay, and we know how to do that. We multiply 5 times 2, and we add the 3. 5 times 2 is 10, plus 3 is 13 over 5. And you know how to do the rest. Multiply the bottom number, multiply the bottom denominator with the whole number, and add the top numerator. For numbers 5 to 8, we are asked to write the following improper fractions into mixed numbers. So we look here and we see that we have 7/3. How many 3's are in 7? So what we're actually doing is dividing. We're dividing 7 by 3. When we divide 7 into 3 parts, we're really trying to see how many 3's are in 7. And we know that there are 2 3's. That's the ugliest 2 ever, but okay. There's 2 3's. And then we have 7 3's. What do we have as a remainder? Well, 3 times 2 is 6, so that means we only have 1 as a remainder with our denominator as 3. Jumping down here to number 8. How many 3's are in 9? Exactly 3. Okay, that would be considered a whole number. And down from numbers 9 to 12, we are adding a whole number with a fraction. Remember that when adding, we must find a common denominator. Okay? If all of these are put over 1, all the whole numbers are over 1, we understand that our common denominator will be the higher number. For example, in number 9, it'll be 8. So my common denominator here will be 8. What did I do to this 1 to make it 8? Multiplied it by 8. I must do the same to the 2. 2 times 8 equals 16. Plus, I didn't do anything to this one, so I just keep the 7. 16 plus 7 equals 23 over 8. That's an improper fraction, so change it to a mixed number. How many 8's are in 23? Let's see. 8, 16, 24. 24 goes over, so 8, 16, so that means only 2. And we have a remainder of 7 over 8. For the bottom one here, number 12, remember to change this to an improper fraction. So 3 times 2 equals 5, plus 1 is 6, 6 over 3. Okay? Sorry, I did that wrong. 3 times 2 is 6, plus 1 is 7, 7 over 3. and then go ahead and solve it with a common denominator. On page 273, questions 1 to 7, we are asked to find the area of these objects. On the first one, we have the back of a calculator. Here we have a floppy disk. This is something that many of you kids don't know what it is because it was before the CD was invented. It was a floppy disk, and that's what we put in computers to save memory. They weren't even a gig, 1 gigabyte. They were tiny. They couldn't hold very much memory. Over here we're asked to find the area of a paper, and over here the area of a flag. Okay, if we go ahead, how do we find the area? Well, in order to find the area, we must use, let me zoom in here so we can let's do these two as an example. Okay? To find the area, we must use the equation for area. And that equation is area is length times width. Or area is equal to length times width. So if we're finding the area, we're just finding the flat part. Let's replace the variables. So again, we write area equals, what's our length? Well, we take the longer part, okay, of the side. This is the longer part. Our area would be 5 5/8 times the width. How wide is it? 2 7/8. Okay? In order to multiply these two, we have to change the mixed numbers into an improper fraction. Go ahead and do that. You already have been taught how to do that from the previous page. So you must multiply 8 times 5 plus 5. Okay, 8 times 5 would be 40 plus 5 would be 45 over 8. 8 times, and then we have 8 times 2, 16 plus 7 is 23 over 8. Okay. Unfortunately, there is no cross-referencing. Okay, because 8 and 45 have no common divisible number. They're not divisible by any common number, and 23 and 8 are not divisible by a common number. So you will have to go ahead and just multiply directly across and multiply directly across. You'll notice that 45 times 23, you can use your calculator, as I said, is 1,035. Over 8 times 8 equals 64. Okay? And how many 64 are in 1,035? There are 16, with 1164 remaining. Let's do question 5 the same way, where we have the formula for area again is area equals length times width. Let's memorize that, okay? Because that is definitely something that will be on the test. And let's replace the variables. At area, our length is 3 5/6 times our width is 3 1/2. Okay, you can see that that's our width and that's our length. As we did before, we can change these, convert these mixed numbers to improper fractions. So 3 times 6 is 18. 3 times 6 is 18 plus 5 is 23 over 6 times 3 times 2 is 6 plus 1 is 7. 7 and 2. Can we cross-reference? Well, no, this 23 is not divisible by 2, and there's no 6 and 7s. These two are not divisible, so unfortunately, we cannot. Let's multiply 7 times 23. And we should have 161, correct? Over 12. How many 12s are in 161? We solved this one in class. Looks familiar to me. There are 13, right? With 5 remaining over 12. Okay, and those are inches. So that is the area squared. On page 274, we're going to talk about gravity, the force that pulls us down. Every moon and planet in our solar system pulls objects toward it with a force called gravity. In a recent Olympic Games, the winning high jump was 7 feet and 8 inches. High jump, when they jump over a pole. Okay? It was 7 feet 8 inches, or 7 2/3. The reason they say that 7 and 8 inches is the same as 7 2/3 is because for every foot there is 12 inches. So really what they're saying is that there was 7 holes and 8 inches out of a foot, which is 12 inches. Everyone knows, okay, that 12 inches is 1 foot. So it's 8 inches, 8 out of 12, so 7 and 8, 12. Well, when you simplify this, how many 4s are here? 2. How many 4s are here? 3. We would write it as 7 and 2/3. Okay? Continue reading. The winning pole vault was 19 feet. Wow. Okay? Pole vault is this sport where somebody runs with a long pole and they stick it in the ground and then they jump really high using the force from the pole. The pole even bends and it kind of throws the person over this bar really high up in the air. Pole vault. This is an illustration of the sport of pole vault, where you run, you use the pole to force yourself up, use the power of it to be able to jump over a bar high up in the air. So 19 feet was the length. Suppose that the Olympics were held on Earth's moon, or on Jupiter, Mars, or Venus. What height might we expect for a winning high jump or a winning pole vault? Okay, on the moon, one could jump 6 times as high as on Earth. So this amount here times 6. Okay, about how in high jump, how many feet would they have? In pole vault, how many? Okay, so remember, pole vault was 19 on Earth, right here, times 6. And high jump was 7 2/3 times 6, and that'll be your answer there. Let's do pole vault just for fun. 19 times 6 would be, if it's 20 times 6, it would be 120. Minus 6 would be 114. Would it not? 19 times 6 would be 114 feet. In the book on question 2, same page 274, it says, on Jupiter one can jump about 3/8 as high as the Earth. 3/8 is a fraction, which means less than 1. If you can only jump a fraction of what you can jump somewhere else, it means you can only jump part of that. So is Jupiter's pull of gravity stronger or weaker than Earth? Well, on Jupiter, one can jump only a fraction of what can be jumped on Earth. This means the gravity on Jupiter is stronger. In order to do question 6 on the Moon, Jupiter, Mars, and Venus, you have to be able to answer questions 1 to 4 above. And it's asking, if you use this actual measurement, about how many feet high would be the winning jump. So what you have to do is round all of your answers. It said previously